Hi. So before we go into the mathematics of automata, I want to talk about two types of automata that there are. The first one, the one we saw in the previous video, is called a deterministic finite automaton or DFA. And what a DFA means is that if I am in a state S1, let's say, then for an input I1, I can only go to one state S2. I cannot go to a state S3 based on this I1 itself. If I am to go to a state S3, then the input would be different. So I can go for an input I2 to a state S3. But yeah, that's what it means to have a deterministic finite automaton. It means that based on the input there is determinism there. I can determine for sure that this is the state that it's going to go to. And the second type is a non-deterministic finite automaton or an NFA. And what an NFA means is that for a state S1 I can have two states that I can go to based on the same input IN1. So this IN1 is for both of these transitions to state S2 and to state S3. So here we cannot determine for sure based on the input which state the automaton is going to end in. And another way to put this same thing is to say that non-deterministic finite automata can have epsilon moves or empty string moves. So basically what I say is for from a state S1 I go based on an empty input to S2, and I can go, let's say, based on an empty input to S3 as well. So as long as there is either an epsilon move or a, double transition based on the same input or two or more transitions actually, then that would be a non-deterministic finite automata. And if there's neither of them, then it is deterministic. And in case of a non-deterministic finite automaton, if if any of the possible transitions lead to a final state, then that input string can be accepted. So basically, let's say I have some string a b a b, and I say that I have a start state S1, and if this is an A, I can go to here, and I can also go to a state S2 if it is an A, and then I say for a B I go from S2 to some final state S3. So now when I actually try and evaluate this string, my cursor is right here, and then I say my first input is an A. In this case I can choose to be in S1 or I can go to S2, and then based on B, this actually is incomplete. I need to say that from A this can stay here itself, let's say, and here I go back on an A, something like this maybe, and from S1 I can say that it comes back to itself based on A or B. This is a comma right here. So I say that I have an A as the first input, so I can choose to stay in S1 or I can go to S2. So when I'm trying to determine my next state, my first state is S1, that's my initial start state, then it's S1 or S2, and then I have a B, which means if I am in S1 I will stay in S1 on a B. If I am in S2 I would go to an S3. So my possible options are S1, S3. Then I have an A right here, which means I'll either stay in S1 if I was in S1, or I could from S3 come back to S2. So my possible options this time are S1, S2. Then I have another A right here, so I'll again be in either S1 or S2. And finally I have a B right here, which means that I can again from S1 I can stay in S1, and from S2 I will go to an S3. So this is the sequence that I followed, and as long as there is one final state in my final state, uh, my set of final states, I can say that this string is acceptable in the language. So that's what it means to have a non-deterministic finite automaton, and it should be able to you should be able to intuitively understand how epsilon moves, and more than one transitions can be just the same things. So let's say I have a state S1 and this goes to a state S2 based on an input 0, and it goes to an input S3, a state S3 based on the input 0 again. Then of course I could do something like this is the same as saying I have an S1, and from here I go on an epsilon, which is an empty input, to let's say S1 prime, and this one based on a 0 goes to an S2 right here, and then I go based on an epsilon again, I go to S1 double prime, and this one goes on a 0 to S3. So in this automaton on the right, I haven't used any double transition except for the epsilon moves themselves. So but yeah, basically any epsilon moves in NFA can be converted to a double transition or a more than two transition NFA, and any NFA with more than two transitions can be converted to an epsilon moves NFA. So if there is either one of them, it will be a non-deterministic finite automaton. And that's it about the two types of automata. In the next video, we'll actually get into the mathematical definition of automata. So I'll see you there.